Lathe machining is a fundamental process in the world of manufacturing. It is a subtractive manufacturing technique. This means that material is removed from a workpiece to create the desired shape. Lathes are incredibly versatile. They are used across a wide range of industries, from automotive to aerospace, and even in artisan workshops. The basic principle of lathe machining involves rotating a workpiece against a cutting tool. This process allows for the creation of cylindrical, conical, and other symmetrical shapes. The importance of lathe machining lies in its ability to produce precise and intricate parts. These parts are essential for various applications. Lathes have played a crucial role in shaping our world. They continue to be an indispensable tool in modern manufacturing and beyond. There are three primary types of lathes: engine lathes, CNC lathes, and mini lathes. Each type caters to specific needs and levels of complexity. Engine lathes, also known as traditional lathes, are manually operated machines. They are known for their versatility and affordability. Engine lathes are ideal for small-scale production runs and repair work. CNC lathes, on the other hand, are computer-controlled machines. They offer unparalleled precision and repeatability. CNC lathes are suitable for high-volume production and complex geometries. They significantly reduce the need for manual intervention. Mini lathes, as their name suggests, are compact versions of engine lathes. They are designed for hobbyists and small workshops. Mini lathes are portable and affordable. They provide a great entry point for beginners in the world of lathe machining. While both lathes and milling machines are essential tools in subtractive manufacturing, they differ in their fundamental operation and applications. Lathes rotate the workpiece against a stationary cutting tool to remove material. This method is particularly effective for producing cylindrical shapes. Milling machines, conversely, use a rotating cutting tool to shape a stationary workpiece. This allows for a greater variety of shapes and features to be created. This difference in operation dictates their respective strengths. Lathes excel in creating cylindrical and symmetrical parts, making them indispensable for tasks requiring precision in round shapes. They are ideal for operations such as turning, facing, and drilling. These processes are fundamental in many manufacturing sectors, from automotive to aerospace. Milling machines, on the other hand, are more versatile in creating complex shapes and features. Their ability to handle intricate designs makes them perfect for custom parts and prototypes. They are suitable for milling flat surfaces, slots, and even gears. This versatility extends their use to a wide range of industries, including electronics and medical devices. Understanding the differences between these two machines is crucial for selecting the right tool for the job. Each machine has its own set of advantages that can be leveraged for specific tasks. Lathes and milling machines often complement each other in manufacturing environments. By using both, manufacturers can achieve a higher level of precision and efficiency. They allow for a comprehensive approach to creating intricate parts, ensuring that the final products meet the highest standards of quality and functionality. When purchasing a lathe, several essential features warrant consideration. The lathe bed, the foundation of the machine, should be robust and rigid to minimize vibrations. The spindle, responsible for rotating the workpiece, should offer a range of speeds to accommodate different materials and cutting tools. The carriage, which holds and moves the cutting tool, should glide smoothly along the bed. The cross slide, mounted on the carriage, allows for precise tool movement perpendicular to the workpiece. The tool post, holding the cutting tool, should be adjustable to accommodate various cutting angles. Finally, the tailstock, located opposite the headstock, provides support for longer workpieces and houses drilling and boring tools. Considering these essential features ensures optimal performance, precision, and versatility in lathe machining operations. Several renowned manufacturers have established themselves as leaders in the lathe industry. These manufacturers offer a wide range of lathes, catering to various needs and budgets. Haas Automation, known for its CNC machines, provides reliable and technologically advanced CNC lathes. Mazak, another industry leader, offers a comprehensive range of lathes, from small engine lathes to large-scale CNC turning centers. DMG Mori Seiki, a global player in machine tool manufacturing, is known for its high-precision and high-performance lathes. Okuma, a Japanese manufacturer, specializes in CNC lathes with advanced control systems and automation features. When choosing a lathe manufacturer, it's crucial to consider factors like reputation, after-sales service, and availability of spare parts. Investing in a lathe from a reputable manufacturer ensures quality, reliability, and long-term performance. Mastering lathe operations, turning, facing, and beyond. Lathe machining encompasses various operations, with turning and facing being the most fundamental. Turning involves reducing the diameter of a rotating workpiece to achieve a desired profile. Facing, on the other hand, creates a flat surface perpendicular to the workpiece's axis. Other common lathe operations include boring, drilling, reaming, and threading. Boring enlarges an existing hole, while drilling creates new holes in the workpiece. Reaming refines the size and finish of existing holes. Threading cuts spiral grooves into the workpiece for creating screw threads. Mastering these operations requires a thorough understanding of lathe tooling, cutting parameters, and safety procedures. With practice and precision, lathe machinists can create a wide array of shapes and features, contributing to the production of intricate components. Safety-first essential practices for lathe machinists. Lathe machining, while essential, involves inherent risks if safety precautions are overlooked. The high-speed rotation and sharp cutting tools can pose significant dangers if not handled properly. Wearing appropriate personal protective equipment, or PPE, is paramount. This includes items such as safety glasses, face shields, and hearing protection. Safety glasses protect the eyes from flying chips, which can cause serious injury if they come into contact with the eyes. While a face shield provides comprehensive facial protection, guarding against larger debris and splashes of coolant, hearing protection is crucial, especially during prolonged operation. The noise levels in a machine shop can be damaging to hearing over time. Loose clothing and jewelry should be avoided as they can get entangled in the rotating machinery, leading to severe injuries. Always ensure that your clothing is snug and that any accessories are removed before starting work. Work-holding devices should be used to secure the workpiece firmly. This prevents the workpiece from moving or flying off during operation. The cutting tool should be sharp and properly installed. Dull tools can cause accidents and reduce the quality of the work. Before operating the lathe, it's essential to ensure the chuck is properly tightened. A loose chuck can lead to the workpiece becoming dislodged, and the workpiece is securely held. Double-checking these elements can prevent many common accidents. Regular maintenance of the lathe is crucial for safe and efficient operation. This includes checking for wear and tear on all components. This includes lubrication of moving parts, which reduces friction and wear, ensuring smooth operation. Inspection of belts and pulleys to ensure they are in good condition and properly aligned, and cleaning of the machine after each use. A clean machine is less likely to malfunction and more likely to produce high-quality work. By prioritizing safety, lathe machinists can mitigate risks and ensure a productive work environment, and create a secure working environment where everyone can focus on their tasks without fear of injury. From hobby to profession applications of lathe machining. The versatility and precision of lathe machines make them indispensable tools in both professional and hobbyist settings. Lathe machining finds applications in a myriad of industries ranging from large-scale manufacturing to intricate artisan crafts. Its ability to shape, cut, and finish materials with high precision makes it a cornerstone in modern production. In the automotive industry, lathes are used to produce engine components, such as crankshafts, camshafts, and axles. These parts are essential for the performance and reliability of vehicles. The aerospace industry relies on lathes for crafting precision parts for aircraft engines, landing gear, and structural components. The high standards of safety and performance in aerospace make the precision of lathe machining crucial. In the medical field, lathes are instrumental in creating implants, surgical instruments, and prosthetics. The precision and customization capabilities of lathes ensure that medical devices meet stringent health standards. Artisans and hobbyists utilize lathes for crafting intricate wooden bowls, metal sculptures, and jewelry. The creative possibilities are endless, allowing for unique and personalized creations. The versatility of lathe machining extends beyond these examples. Its adaptability allows it to be used in a wide range of applications, making it a valuable tool in any workshop. It plays a crucial role in various other sectors, including energy, electronics, and construction. In the energy sector, lathes are used to create components for power generation and distribution. From shaping raw materials to creating intricate components, lathe machining continues to drive innovation and manufacturing across countless industries. Its impact on modern technology and production processes cannot be overstated. Conclusion: embracing the versatility of lathe machining. Lathe machining is an indispensable process in modern manufacturing and beyond. From traditional engine lathes to advanced CNC lathes, these machines offer a wide range of capabilities, catering to diverse needs and complexities. Understanding the different types of lathes, their essential features, and reputable manufacturers is crucial for making informed purchasing decisions. By mastering lathe operations while prioritizing safety, machinists can harness the power of this versatile technology to create intricate components for countless applications. As technology advances, lathe machining continues to evolve, pushing the boundaries of precision and efficiency and shaping our world. From industrial giants to artisan workshops, the enduring art of lathe machining remains a cornerstone of innovation and craftsmanship.